Hey everyone, we finally get panel 2 started. As the title already suggested, that this one will be addressing the security challenges. We all know today's internet facing security challenges. Lots of progress has been made. More threats are coming along. So as we stated here, I quoted Steve Ballon, which is a well-known researcher in the security area, who said that security seems to be is a reactive discipline. We find ways to fix the problems identified. Now, the ongoing question, which is that for each threat we fixed, how much that fix can actually mitigate the future threat, and where the future really going to end up with. And meanwhile, NDN started looking into a new way to mitigating the security threat by proactively building this crypto protection layer into the system. Of course, in addition to that, we still need to detect and react to the threat that perhaps could break your original protection layer. With that as a background, for today's panel, we're gonna just talk about where we are, both in terms of the current stage of our affairs and also in terms of our understanding where NDN research is and how that may help mitigating the identified security challenges across the global internet. And we are having this 4 panelists. It's our pleasure to have them all here. There's Alex. I think most people here should have known Alex. He's been with the NDN starting from the early on. That has been working on the NDN security for so many years. And then there's Randy King next to Alex. And Randy also has been in this community for some number of years now. And the difference is that Randy actually on the front line developing solutions to mitigating security threats in the real world. And then we have Zhen Ma. We're going to have a round of introductions. This is a brand new name to this community. And he'll help us explaining where the front line is in terms of the security research. Then finally, but not least, we have Jay Mishra. Jay is a well-known name in the security area as well. And in particular, in recent years, he has been working on the security challenges in the critical infrastructure area. So Jay will have a lot to share with us. Having said all of that, we'll first have a quick first round of introduction, in particular for the 2 online panelists, to get the audience know them a little more better. Then we'll go on with the discussion questions. Maybe we'll start with the same order. Alex, you want to say a few more things that I missed about you?
Well, I think Lisha already covered most of this stuff. So I've been with NDN project for a long time. I mean, I was with the UCLA, with FIU. Now it's a little bit on the private side.
Yeah, so most of you probably figured out who I am by now, and maybe I'll say a little about Operant, that we started in the renewable energy space and stumbled on NDN as part of a broader solution, and then found that we sort of think we have a nugget there. Over the last 7 years, we've evolved to critical infrastructure and more in general than just energy. And so I can later share some practical aspects of how do you sell security, because people don't actually buy security. So it's an interesting question. I can tell you a lot of things that don't work and a couple that might. So
that'd be really interesting.
Yeah.
We're looking forward to hearing that. Next one, Zane.
Hi, everyone. My name's Zane Ma. I'm a assistant professor at Oregon State University. And my research focuses on mostly web PKI and understanding kind of the whole complex system of CAs and browsers and subscribers. But I also have done some research on DNS security and looking at other emerging protocols. And I would say the broader theme of what I'm interested in is identity and authentication on the internet. And so web PKI being sort of the biggest well-known example of that.
Thank you, Jane. Jay?
I've been working in the cybersecurity area for almost 15 years now, so 15, 16 years or even more. But I started working with Leisha and Alex since 2014. We have been in collaboration since then. My area of research predominantly has been on edge computing security, and critical infrastructure is one of the dimensions. There we have been looking at the power grid, now looking at advanced manufacturing. We also do stuff with disaster response and how do you build networks for disaster response, and then how do you build trust, security, privacy in those kind of networks. So that's been what I've been focusing on with my students. We have many other areas of research. I tell people that I suffer from research attention deficit disorder, so I want to solve every new problem that I see that is interesting. I'm happy to be in the panel. Thank you again to the team for inviting.
Thank you, Jay. So we are going to move on to the next question. That is, what's the current state of affairs in terms of security challenges and mitigating solutions? And following that, I think we're going to have a mix of both the current situation, but also together with the question, how NDN can or may help. In all of these discussions, I'd like to focus on one thing I think is perhaps the most useful. That is, what are the perceived biggest problems, and identify the remaining challenges. Because for us, this meeting is like a research collection. We really want to know what are the big issues, and then see how we can develop effective solutions to mitigate those problems. I will start with Zane, given that he mentioned he's in the front lines about water security, what's going on with regarding the solution development. So I will let him start it first.
Yeah, I mean, I was asked to kind of summarize my views on the state of network security, and that's a little bit of a tricky problem. But I think one of the things that became very apparent, that has become very apparent in recent years, is that in many ways, security or lack of security or the difficulty of security has been a driver in the recent centralization of the internet. It's been a centralizing force. So yeah, security is really hard to do and to do well. And so this has kind of led to congregation of network resources behind a few moats. So if we look at a few things like user authentication, right? More and more websites and services are now just using single sign-on instead of implementing their own authentication systems for users. We have DDoS. This is still a very prevalent issue, and anyone who's starting up a service is most likely going to use a CDN in order to protect against that. And then, yeah, on the other side of the problem is also clients. Clients want privacy. They don't want their IP address tracked and stuff like that. And so you see a lot more utilization of VPNs, and the other side of the VPN thing is also servers, right? Servers that want to have or limit unauthenticated access to certain resources will also use VPNs, with new protocols and technologies such as WireGuard becoming very popular. Yeah, so for a multitude of reasons, security is hard for individual sites and services to do, and you can just go hide behind someone else's wall. The one area where there has been, in my mind, a little bit of a opposition to this trend is in TLS server authentication. So while a lot of CDNs provide free TLS services, getting a web certificate these days has never been easier. And this automation has allowed some degree of remaining decentralization or distribution. So anyone can just, set up their own website and get a web certificate for it automatically without even having to really configure much. And so, if it were harder to do TLS server authentication and get your own certificate, you might expect even more people to jump behind a CDN because they'll just provide that service for you. But yes, given that we have this sort of centralization or these large moats or walls that people are hiding behind, we are getting a lot less end-to-end encryption, right? Usually, what is terminating connection is some middle box, or terminating the encryption is some middle box like a CDN or even a VPN, and so that I think has some downstream consequences as well for security. Yeah, these are kind of less organized thoughts, but some other observations is, yeah, traditionally, a lot of network monitoring had relied on packet inspection, deep packet inspection, stuff like that. But the growing use of encrypted transport is making that harder and harder. And so we're seeing growths or increased importance of host-based monitoring or defense, where we can get around, we can view packets before they've been encrypted or after they've been decrypted, or TLS interception network monitoring. So a lot of enterprises now do TLS interception for clients on their network. And this requires, installing your own trusted routes for, the devices you want to protect. All of the internet is sort of based upon, the security of routing, which kind of often goes ignored. But even though things are improving for routing, our deployment is increasing, and now we have ROAs for about 50% of announced routes. Which means we actually have pretty good security or defense against, misconfiguration when somebody fat fingers their AS number or, the origin of a route. But this doesn't provide much protection against targeted attacks, right? You can do sub-prefix hijacking, you can do shorter routes and stuff like that. So yeah, all of this is still built on a semi-shaky foundation. And then even beyond network security, there's movement towards memory-safe languages just for protocol implementations and whatnot, and that's great. And at least in academia, there's also been some more work in formally verifying protocols and the implementations themselves. But this has, in my opinion, not really shown a ton. Like, it's unclear what the end benefits are of this work. For example, TLS 1.2 has been formally verified many times, and still we see big attacks like Heartbleed and things like that. And part of it is just the scale of some of these protocols and systems is beyond what you can formally model or verify. So there's still challenges there. And then finally, I think one thing that's on everyone's mind is AI. And so, yeah, my view on AI is that, this is a tool that is increasingly used for attacks and defenses. And because AI, as anyone who's played around with it knows, AI is imprecise. It can hallucinate, it can make things up. You would never rely on AI in its current state for some mission critical system. And because of that imprecision, it seems like it may provide more benefits for offense where, hey, you don't need to do everything correctly. You just need one vulnerability for AI to succeed at an attack. Whereas defenses, you do want more reliable and deterministic protection. And so AI may not really fit all the needs there. So yeah, there's been a lot of work in adversarial machine learning against network AI defenses. So to summarize, like, what do I think the hard problems are? Again, this is a bit biased just because I work on public key infrastructure, but I do really think that establishing public key infrastructure is really hard. Not just for the web PKI, but for RPKI for routing, DNSSEC. Now people are talking about binary, a PKI for code signing. Yeah, this is just a really hard problem. Coordinating with real world entities, developing security policies is challenging. Also, we need trust in order to scale. You can't do everything on your own. And so, at least in the Web PKI, the model that has seemed to work so far is, we trust but verify, but we don't verify everything. We verify probabilistically to make sure that CAs and other participants in the Web PKI are kind of upholding their end of the bargain. I think NDN can provide some really interesting solutions or approaches to solving this hard problem because it aligns the identity space with the trust space. This is not the case in the Web PKI, where we are trusting CAs to verify the identities, anyone's identity. And there's not some sort of internal accountability where, hey, if a CA fails, they're only affecting the identities that they're responsible for to begin with. But that seems to be the case, in DNS and other hierarchical systems like NDN. Another hard problem is usable security. At the beginning, I talked about centralization behind moats. I think this is because it is hard for network hosts or operators and participants to just plug and play and have secure defaults. And instead, they need to rely on some big tech company to provide security for them. And so I think one direction that's important for this is automation. If we can, automatically configure and secure different networks depending on their respective needs, I think we can hopefully move away from this sort of centralized topology that we are moving towards. And then, a little bit unrelated is that writing secure code can be challenging, not just for networking, but for, any sort of software. So, this is just sort of a problem that everyone is facing and not necessarily specific to network security. So that's kind of my quick overview. I'd love to hear if others agree, disagree, other perspectives. Would be welcome.
Thanks a lot, Zane. I think next I'd like to invite Randy to say a few things. Now, Zane said what's going on from his viewpoint. Now, from your point, how the world actually looks like.
Well, this is really convenient because I was about to say that I almost 100% agree with you, Zane, on your topics, but I was afraid I'd forget them by the time my turn came around. So being next is useful. But the mode of centralization is probably the biggest barrier to change in the security world, because the big players, let's use Microsoft as an example, they have the ability to pull all the customer data and processing into a single cloud infrastructure where they can apply all kinds of microservice architectures and accomplish pretty amazing things from a security and a convenience point of view. So it's really hard for any kind of independent or piecewise solution to compete against that. I don't know what you'd call it, but the galactic headquarters approach. So a lot of startup people basically are building point solutions that are demos to get acquired by the big people because they can't really compete for long generally. And that's not good because that just sort of reinforces this silo thing. The angle that kind of works, and I think may give an opportunity to drive a wedge into it, is that there are applications, and like Jay's aware of a lot of these, where people are not going to connect things to the Azure cloud. I mean, critical infrastructure is very touchy about where their data goes, and there's all kinds of regulations and security aspects. That said, Microsoft's trying to implement secure gov clouds and things like that, but there'll always be a certain resistance to it. So that's where we've found some success. And within that, I do think this concept of PKI in a very general sense is the underlying problem that's about to get a whole bunch worse, that would allow NDN to maybe make a contribution, which is recently the concepts of non-human identities are getting a traction in the VC space, where people are really interested in the identity of a workflow in a corporate environment, an application usually containerized. What is that exact identity? What is the identity of a service? What is the identity of a person? What are the identities of machines? And what are the identities of AI instances? And when you look at all these disparate identity chains, they all have their own authentication and authorization protocols that exist and serve meaningful purposes. And so it's not possible at this stage to centralize all the credential systems in a meaningful way. So in order to talk to all 5 of these kinds of entities I mentioned, you need about 20 different authorization protocols, starting from simple certificate-based stuff, TLS, whatever, and there's, OAuth tokens and JWTs and all kinds of different credential systems, Spiffy Spire for CI/CD stuff. And Microsoft has pioneered trying to integrate connectivity to all of these different authentication and authorization systems and deliver them where they're needed in a big network using, I would say, the 3 or 4 most advanced protocols to deliver the lesser protocols where they need to go. And that works really well in the Microsoft ecosystem. I think one of the things we're really interested in is building a trust delivery system that can deliver these credentials via NDN using strongly authenticated identity and trust rules. We can deliver a specific authorization token to an entity for use for 60 seconds and let it evaporate. So we're basically delivering the existing protocol credentials where they can be used. And that allows us to sit on top of a lot of systems rather than change the way they operate. So this is an area where it's sort of like a super PKI, or maybe there's an actual term for this, Zane, where you're cutting across all kinds of different authentication protocols. I find it of great interest because I don't think industries face this yet at all. They don't really understand what's coming. So,
Thank you, Randy. I think that's really interesting, especially you mentioned about this 5 ways of 5 different spaces, why to do identification and authorization. That's really interesting. Now, next, let's have Jay give us his view on the current security challenges, especially regarding to the critical infrastructure.
So just to go back to what Alicia mentioned that I should focus on is cybersecurity. I changed it a little bit to call it cybersecurity at the critical edge, and I'll tell you why I mentioned that. So if you look at the edge, so this is a fairly growing portion of the infrastructure. So when you look at the core, we're not really growing in terms of equipment. We are growing in terms of bandwidth, etc. But at the edge, we are really growing in terms of equipment and devices. So for instance, latest forecasts across multiple dimensions on the critical infrastructure. And when I say critical infrastructure, I'm talking about power, energy, transportation. You're talking about other things that are somewhat allied. Water is another, and there we are constantly deploying more and more devices, which is adding to the attack surface at the edge. But also, it puts an interesting challenge at our doorsteps, and which I think Zain and even Randy alluded to a little bit, is we are now talking about all these devices where we need to be able to do key management, key exchange, and guarantee freshness, so that we can trust the data that is coming out of these devices and the control messages we are sending to those devices. And essentially, as you add more and more devices into the mix, then you're kind of becoming a challenge to be able to manage all of these. Beyond that, as you go into the critical infrastructure, generally in the critical infrastructure space, it is divided into operational technologies and information technology. Operation technology is all the things that are at the edge. Information technology is your back offices where you gather all the data, crunch numbers, provide the CEO and CTO information. But and OT or operation technology has been kind of getting meshed into the industrial control systems perspective, where we have all these devices at the edge, we are communicating with them, we need to have security, we need to do access control, we need to do all these things. But because of the convergence, rapid convergence that is happening between IT and OT, and which is driven by the interest of machine learning and having intelligence being pushed to the edge of the network so we can do intelligent decision making faster, What is happening is IT is moving into the OT space. And there is a clash of principles, so to speak, where IT has always been, oh, we're going to firewall things, we're going to restrict this, we're going to not be able to communicate this, we're going to do access control for this. Whereas OT was more about gathering data and transmitting to the core to the aggregation points in the network. So these are coming up in collision with each other. And we are seeing now, and increasingly so, more data moving up from the wider reaches of the network in rather than going down. So that is opening up challenges of data provenance. And data provenance is actually not the right statement. I misrepresented here. It's more of a challenge of provenance. So provenance of devices, provenance of the software that we are using, and not only one single piece of software, but the multiple combinations that you use of libraries, archives that eventually lead to creation of the code that runs on your devices and you interact with them. But also provenance of data. And data provenance is becoming even more complicated, and I'll talk to you a little bit about this, but also to mention what Randy said, compliance versus technology is becoming a trade-off. It's not like we don't have cutting-edge technology, but if you think of cutting-edge technology and you ask me, is this being deployed on the power grid side, or is this being deployed in the water management and water infrastructure side? The answer is no, because there is a big challenge with being compliant while trying to involve new technologies into the mix and guaranteeing that you don't get into a situation where there is a breach that happens and you get penalized for it in many different ways. So that's kind of the landscape for it. And I wanted to give you a couple of examples of things that we are looking at and I thought might be interesting at the critical edge. One of the things that we have been looking at is how do you build resilience into the power grid? So resilience into the power grid, if you look at it from the NDN construct, what we have done is over the last 4 or 5 years, looking at named data networking as an approach to build a grid infrastructure that is more advanced than what we have today. But also what we are trying to do, and we've been successful with it. We've got funding in the past, we have written papers in the past, but now what we are looking at is, as you see more and more devices at the edge, there is a greater chance of them being commandeered and you potentially having more highly efficient denial of service attacks or distributed denial of service attacks. So what we've been looking at is how do you build backup and reliability into the system to increase resilience and potentially use wireless, so cellular networks like 5G and stuff like that. If you're interested, we can talk more about it. These are just pointers that I wanted to put in your thoughts in your mind so that we can discuss this more. The other aspect which is becoming critical is manufacturing. So, with onshoring of manufacturing and greater emphasis on manufacturing being what we want to focus as a country in the future, there is a need for us to do truly distributed manufacturing because that enables us to bring more people into the workforce and be able to do greater social change and social impact. So what we have been looking at is distributed intelligent manufacturing and really to try to build the foundational cyber infrastructure. So you could do manufacturing at the distance by sending information that is potentially copyright, intellectual property, preserving it, ensuring that the printing that is happening at the edge is trustworthy and somebody is not printing something else while they're saying they're printing your stuff. And also your intellectual property will not be challenged, but you also not be litigated because what you said you're going to print is not what you printed, what got printed. So these are certain things that we are looking at, and that's actually a big scope for utilizing named data networking, and I'll talk to that in a little bit. The last thing is looking at machine learning is becoming very important, but machine learning is actually also getting pushed to the edge with edge computing, with all these NVIDIA GPUs, which are fairly small, that they can be deployed at minor server class machines at the edge. So what we have been looking at is, if I run a machine learning workflow at the edge, and I say that you told me to do something, I did it, then this is the response. How do you even trust the response? So that is going to become very critical. Because as we add more and more intelligence at the edge, and we get more aggregated or analyzed data that we don't have access to the data, we are getting inferences and analysis. We need to be able to verify and trust the outcomes of the compute that is happening at the edge. So these are certain things that I thought were critical in the context of the edge. So now I'll just talk about one thing and stop here. So when you look at, if you ask people where is the innovation happening across the application space in computing today, everybody talks about machine learning, large language models, this and that. There is one potentially very useful application of machine learning, which is distributed and federated machine learning, where the idea is that, instead of me sending all the data that is going to be generated at the edge, and I don't have fat enough pipes going up, so what I would do is I would do either efficient aggregation or create models at the edge that I would eventually create a hierarchy of models that travels up and gets aggregated. And these could be multidimensional models, multimodal models, and you can combine all of them and build intelligence at different levels, but more so aggregated at the edge, aggregated at the cloud rather than at the edge. But do so in a more efficient manner. Now, in that context, I'm sure all of you have heard this. Your model is as good as your data is. So data is no more the king. Data is actually the emperor. So as a result, as we are building more and more sophisticated models and pushing the decision making from the human to the machine, what we really need to care about is the quality of the data, the accuracy of the data. How can I trust the data? And then when you create a provenance chain of data, where I'm aggregating data from multiple locations, I'm creating machine learning models, which then inform more aggregated models, which then inform further aggregated and more refined models. How do I create this provenance chain so that I can quickly identify if there is a problem, where could it be? And really, the goal is to be able to build trustworthy, dependable, and robust models. And the whole idea, at the moment I say this to you, you quickly realize that, the amount of data we are going to be pushing up the pipe towards the cloud is going to increase more and more. And that is where the advantage of NDN comes into picture. So if you look at named data networking and the ability to verify data that is coming in, be able to check the signature of both the interest and the data if you want to, be able to check the signature on the machine learning models that are created, be able to build provenance chains on the model so you can actually follow through from the model to the data set that has trained the model all the way across multiple levels. I think that will be a major advantage that NDN provides. And I'll stop here. I don't want to go too much into detail. We can discuss more.
Isha, could I make a comment?
Great.
I'd like to go back to something you said a little earlier, Jay, which is the struggle of compliance against new technologies. One of the things we've learned at Operant that was surprising, and I wouldn't have known it when we started, is that in the security space, the early adopters are not the small, nimble startups. They are the government and the very big corporations. Those are the people that are willing to change fastest because they have the most detailed understanding of it and also a lot to lose. And so we've actually had good luck. We've got NDN running today on over 10 gigawatts of centralized power plants, all levels of NERC-CIP compliance, which is a fairly robust cybersecurity thing, including medium level. And medium level in NERC-CIP means up to a gigawatt site, or even a little larger. And so, and then by the end of this year, we'll be deployed on almost 500 middle scale solar plants across the country, again being compliant with the NERC-CIP stuff. So it really isn't a barrier. I mean, we had to work a lot with DOE and the national labs to get to that point, but that's one of the things this research community made possible because we were able to establish some credibility from the work here at UCLA and the associated schools, and then transfer that to labs and then build some credibility with DOE. And now we're recognized as you can deploy us and it's just okay. And that's really a strong sales point for us, which is people don't want to think about security. So I wouldn't, if you have an idea for something or a research project that seems like it would run into a regulatory barrier, I wouldn't discourage you from pursuing it farther because it can be overcome. They're literally looking for solutions to these kinds of problems. I wouldn't have known that, 8 years ago when I first met you. So.
Thank you, Randy, for this very encouraging news about the big guys, I mean, especially government, actually are willing to move forward or have the interest to move forward. But if I summarize all the previous three talks, that seems to end up with very high hope on in the NDN direction to develop effective solutions. Now that's Alex to say something.
Well,
Reflecting his.
You're going to give a balancing view?
I'm not sure I can give a super balancing view, but I kind of there are 2 points that I took out from the previous speakers. So one item was the focus on centralization, or kind of the current security environment kind of relies a little bit too much on the central component. And those central components are not necessarily needed in the environment. And specifically, like for example, we can get back to the PKI system. In the PKI system, I mean, it's working for the web security in a reasonably well fashion now, even though it's still not necessarily correct. So for example, I mean, everybody can get a certificate as soon as they have a DNS name, kinda, but they have some in local environments, in the same like a power plant. Some of the machines, some of the servers that you want to have even the same type of channel-based security, you cannot get that certificate because you're relying on a central internet scale PKI, I mean, a certificate authority, in order to give you the certificate. The system, even though potentially the protocol-wise it's designed to be more flexible, we don't have that ability, but to deploy the same certbot on our local environment so that I can issue the certificates myself, issue sub-certificate, and the whole system is working. It's kind of not designed in this, the whole internet is not designed in the same way. So this is what in NDN, I think from the day one, we try to accomplish is that we have a naming as a kind of essential component of everything that is being exchanged, everything that is being communicated over this NDN network, being it some kind of identification of the channel that you want to secure, I mean, in principle, being its actual data, and then the identity that you issue and the kind of certificates that we're dealing with are tied, kind of, there's no centralization component that we try to build in the protocol, even though like, maybe some of the initial deployments still relied on a centralized component, but all the tooling allows you to become a CA. I mean, not a CA, but rather an entity to issue a certificate. And like you launched the application, you got the certificate. That application created a bunch of sub-certificates for different use cases, and that is what I think missing in on the current environment. I mean, identity. We had a conversation yesterday about whether it's a problem, it's not a problem. I mean, how to create identity, like how to verify, it's not our question. Like it has to be done somewhere else. But the identity representation is potentially our question, because you have to have agreed upon common way of represented identity, so it can be used if you want to use this identity or different identity to represent something or authenticate with. Right now, we don't have a central solution for that. I mean, I'm not necessarily would agree with with Jane. He was talking about the single sign-on, the kind of future direction. I think it's not a really future direction, but rather a hacky direction, because people are a little bit lazy in developing a solution to do some form of authentication. If there was an easier way of dealing with identities, like generating identity, and I think we're kind of getting there with passkeys, like it's a little bit going in that direction, so it's becoming easier to deal with, but still, we need more. I mean, NDN kind of provides one universal architecture to cover all the aspects of security, identity, like issuing sub-identities, sub-securities, and so forth. And the third point I would like to make is the focus on kind of data. Like I think even Jay mentioned, and you mentioned, there's a lot of that is in the current environment is not really focusing on protecting the data itself. I mean, yes, there are solutions. In principle, we do have end-to-end security in some of the applications, like WhatsApp potentially have some end-to-end encryption or end-to-end security. But that's really not universal solution to anything. You cannot have provenance of the data, you cannot have identification, I mean, the privacy of the data. So that's kind of a big problem in today's environment, and potentially NDN have great solutions for that, because you have one format. I mean, I wouldn't say it's like one solution, but it's a one format that can be used on the network level, on the storage level, on the cache level, hopefully in the application level, processing level. So those kind of interesting ideas that I think we tried to explore already, and I think we should explore a little bit more.
Yeah, I think AI will really help with understanding securing data as what do they call it, a first-class citizen. Like when you start doing semantic vectors and things, and you start realizing that you've moved into these abstract representations of data that you can no longer trace back to their roots easily. Technologies like NDN can provide, immutability and, I guess, provenance of where it came from throughout a chain of reasoning like that. And there's a lot of interest in that stuff, but AI is moving so fast, and security is getting farther behind every day in that field. So
I would add that AI is, in my mind, also part of the problem, creating a data problem. AI models have gotten really good at creating content and data that is indistinguishable, from any metric from real data. For example, it can generate photorealistic images of, let's say a politician doing something crazy, and there's no, maybe there's no visual artifacts or anything to distinguish whether that was real or not. And, that happens not just for images, happens for videos, for network data, any data. And so we really are having a authenticity crisis with data. Before, when somebody had a blog that was artificially generated, you could kind of skim the text and tell, like, okay, this is a little weird. But, now AI makes it so that there's no artifacts of AI generation. So there's actually been a lot of industry movement in this direction. Adobe is one of the leaders for Content Authenticity Initiative, where they are trying to handle data authenticity and provenance through kind of traditional PKI. If you've heard of the C2PA, that's kind of the organization or the group that's starting to do things. But I think I haven't looked too deeply at one of the challenges that they face is really, what is our underlying namespace, and they're trying to solve the similar questions about, how do we design the system so that when you take a photo with the camera, the hardware is going to sign it and say it's created by this vendor, and then if somebody goes into Adobe Photoshop and edits that, you can also track the edits that were made to the image and so on and so forth. So, yeah, this is definitely a problem that is already here. And definitely we don't really have any good solutions yet.
If I chip in just a couple of sentences, I think for one, although the panelists talked a broad range of issues, but there seem to be common elements. For example, Zane mentioned about the data provenance from the media viewpoint. I think that actually echoes back what Jay said earlier with regarding to the provenance of the edge data. Although there are different problem spaces, but the problem itself is really the same thing. And that relates to another issue, I think it's also across the panelists. Alex mentioned about this fundamental question of how we do the trust management. Essentially, where is the PKI? The current solution relies on the central components. It's web PKI. Right, that's what Zane mentioned. And I think the current desire for solution, the new solution, actually is to figure out how we can do the trust management in a decentralized fashion. I think that's really important. Yeah, I just say this. So I just echo back what people said, and only I think actually Andrew said specifically this question, that is how we can do the trust management in a decentralized way that still assures the security.
One of the things we've realized is that we want a fairly centralized management of trust, but we want a decentralized enforcement and documentation of trust. Because in our world, there is someone who's in charge of the domain. It's not a full internet solution that we work on. It's a limited domain where there's an owner who owns the trust system. And that simplifies a lot of the problems. Sort of similar to the discussion on the previous talk about trust zones. If you have a specific problem, a lot of these things become more obvious.
Right. Yeah, I think here you're talking about centralized control for individual trust zones.
Right.
I think today we also have this central components, which is the whole
The
world.
authority system.
The whole world has this set of so-called certificate authorities. So that's really the big challenge.
The other thing is, when I think about the scope, so you're generating data at some place, you're moving it somewhere else, you're generating inference at that place, and then training a model, and then you're sending it somewhere else. So you also need to translate the trust across the system. So, we don't even have a way, or we haven't thought about this because it hasn't been used as much so far, but it will be as we move forward. How do I even aggregate trust? For instance, I take a device, I use some software, I generate some data. What is the total trust score of this whole combined? We don't know how to define that well. I mean, for those of us who have done optimization, this becomes a bi-criteria or a multi-criteria optimization problem, which there is no optimal solution that is in the space. But really, how do we even codify all of these dimensions so we can create a notional idea of trust? I mean, if you tell the end user, I trust the device 90% of the time, I trust my software 100% of the time, I trust my data 60% of the time, how will the user define what is the trust in the system? So that's going to be a big challenge, and we need to be able to migrate that trust across the chain.
Again, if I chip in my 2 cents. So yesterday we brought up this notion of trust plane. That is to say, among all the things in the physical world, there's actually relation. Devices, human, applications. There's some intrinsic relations actually among all of us. Whose device that is, and whose application, who wrote the code, things like that. I think you brought up, Jay, a really great question. That's normally people will say, right, get a piece of data from a sensor, how much trust you put onto it? And if one applies this notion that the trust relation actually exists a priori before the connectivity and before the sensor actually produces data. So that goes back to the question, who's the sensor that is, right? Maybe this the provenance question not only applies to the data, but applies to all the other things as well. The devices, the applications, so that we can collect those things together. This is easily said and done, but ideally, right, if you can thread out all those relations, then maybe there's a hope you can derive a trust relations among the so-called entities, which is anything that may produce or consume data.
Right, and my statement was to say that with name data networking, if you can percolate it across the device, the software, the data, and in a way, anything that is on the network has a name, right? So you actually have the building blocks of being able to build this infrastructure so you can actually build the application that is defined by the trust score.
So I just had a comment, sort of what your thoughts are about what Zane said earlier, the example with the camera assigning what images it takes. And so my view is that trusted execution is sort of a generalization of this idea that you will kind of mark the content or whatever is generated, the data that is generated at source on how it was generated. And so I think that in this context, naming becomes even more important Because if you're talking about an image, then it's like self-descriptive. It's like a photograph, you can look at it and a human can kind of tell what it is. But if it's like any other form of data, then to be able to use it across domains, it needs to have a descriptive, semantically meaningful name. And so that would become like, now you can't attach that name on top of it. It has to be generated at the source. So I don't know what others think of that.
Yeah, I think a good example is just training data for AI. You label it and name it at the source. Now you train it, and you can track the progress of that data through the training process. Otherwise, you're just going to lose its identity immediately.
And the other thing that I find fascinating is, so when you say that my camera took a picture, and then I'm sending it, so I signed the picture that was taken by my camera. So there itself, there is a disconnect. Because how do I know that what the picture that my camera took, it was not in any way compromised when it was moving from the camera hardware itself, or firmware, if you may, to my operating system, gets packaged into the application, then gets sent out. So if you really are, as cybersecurity researchers, to some extent, we have to be paranoid, right? So if you're really paranoid, you need to look at the point of origin and be able to track every single thing, so that if nothing, you can at least apportion the blame on a particular location and do it accurately. So that is going to be an important facet of being able to, because the amount of data that is being generated, the amount of inferences that are going to be generated in the future, trusting all of these is going to become a challenge. And Sayan gave a good example, but it's going to be true for all kinds of data that is out there.
Yeah, Jay, Apple's new Apple Intelligence structure, they're going to offer people to audit their TEE-equipped server systems, because the only way to verify that they're doing what they said they do is to allow third parties to, run test cases. And things like that might become pretty important, right?
So, Tolga?
Yeah, hi, I'm Tolga. Hi, Zane. So, Randy, actually, you told a very inspiring and quite systematic story of how you guys penetrated, like, the market, right? Building academic credibility in, like, national labs. I was wondering, when you were going through that journey, were you actually trying to convince people of how NDN is doing something? Or did you have your own business model, your own pitch, where NDN was just means to an end, right? How much due diligence were you subjected to in terms of proving to people NDN does it a certain way? Or rather, were you just like, we're doing this, and you abstracted out the means? So the reason I'm asking this question is because yesterday, there was a much more application-oriented discussion where let's build a killer app, and then that's how we convince people. Today, it seems much more like an ecosystem-based way to sort of convince people to adopt NDN. So from your perspective, what did you do? How did you approach this?
I can't say. I can tell you what we did, which sort of eventually meandered, random walk to maybe a good place, but I don't know that it is the best way.
All right.
But we started with a very technical approach, because all we knew was what we learned from the academic community.
Okay.
And so we exposed all that to the national labs and let them get pretty deep in it. And that provided us our initial credibility. Like, Jay, you remember maybe back a long time ago, you helped us at Sandia. Jay went and gave a lecture, right, like to the Sandia guys. That was our first exposure to the national labs.
Okay.
And they looked at it, and at the end, they're like, this is great. Like, here's a report saying it's great. I mean, they didn't really understand it. Like, Jay confused them probably, but they believed it. And now we've gone through that cycle at different labs like INL and NREL and stuff. Then we've exposed through our corporate connections, there's security firms like Dragos that have done red team testing and stuff. So I'd say we've been somewhere in the middle of, a white box testing. Let's really understand it. There's that other aspect you mentioned, which is most people at the higher levels of corporate and government thing just want the scientists to tell them it's okay.
Yeah.
And they just, once they hear that, they're sort of done with the conversation. So it's an evolutionary thing, do you mean?
You're saying that you had the idea, or when you went to the national labs, did you go to them with we're going to adopt NDN, this is how we do things? Or they even know you were using NDN when you first went to them? Obviously they knew, but how much
it was an attraction for them.
Okay.
They were actually like, oh, that sounds cool. We'll go in on a research grant. Which is,
NDN itself was the selling point.
yeah, absolutely.
Okay. All right.
Leisha's name, all this stuff is really valuable there, right? Like, because national labs are tasked with moving things from academia to industry, right? As part of their charter. So it's a good thing. The research community and the engineering-focused research, not NSF stuff, but DOE and things like that, that works.
Okay.
And, you know, now I walk around DOE and everybody knows who we are, but it took 8 years, right?
Sure.
But it's not as hard as it would seem. Like, that's why I was trying to be encouraging. You know?
Yeah, that was very inspiring. Like,
Just want to understand, this is pretty inspiring, especially I think, Jay, what you mentioned about the federated part, right? However, what I want to understand is because in many cases on the edge, we deploy the same application which is public facing, right? It's not expected to be too secure. And a web application may comprise of various assets which are coming from different locations, right? And some assets could be, for example, very protective in nature. Some assets could be very public facing, right? It's a general information. Now, how do you marry, this kind of heterogeneous environment when, there are a lot of complexities, right? So from which edge you are being served? First of all, the certificates of security needs to be bootstrapped. Then within that itself, there are various concerns, various, I would say, to pardon my knowledge, but zones itself within the application, right, with different security level. So are we not moving towards a very complex, because in IP era, it was just that IP that is being protected, and the DNS is, for example, if you have HTTPS, then you're just validating that it is certificate is secure, it's validated, but the content of certificate you don't bother. At least a Chrome or any browser doesn't bother, right? So how do you manage that with NDN? How do you foresee those kind of public facing things when deployed in a distributed environment? How will that improve the security? Because private kind of deployment, I really understand, it is meant for a specific purpose, you can secure it very well. But for a public, deployments of applications, it is, according to me, pretty difficult to achieve the same level of, security. So any comments on that?
That's actually a good point. But if you look at historically, the way we were looking at things in terms of security, we have always been securing the endpoints and the network. We have never thought about securing the data. And if you ask me, what was the biggest takeaway that I had when I first started looking at future internet architectures and paid attention to NDN? Remember, there were 4 or 5 that were selected, and finally there is one or two left behind, and NDN is the more popular one. I think the biggest takeaway for somebody who understands networking as well as cybersecurity was, we are really worried more about the data rather than the devices that are handling the data. And if I could secure that data and encapsulate it correctly, then I don't really care what device you're running it through. And I don't really care, I care about the source because that's the origin point of the data, so I need to validate it. But beyond that, it could flow around in the network, and I wouldn't mind any device that is untrusted to be able to handle it. So that is one point. But as what you mentioned about having public facing infrastructure, so public facing infrastructure need not be untrusted, it can be trusted. But I think what you're trying to allude to is, if let's say I have 5 different cameras, 2 of them are of my own and 2 of them belong to my neighbor. Now there is let's say I'm running an aggregation service because AT&T pays for it or T-Mobile pays for it. If I gather all of that, how do I prove to whoever is taking my information that I aggregated from 4 cameras, 2 of them I don't have any access to them, so I don't even know if they captured the right image or not, right? So that is what your I think, is that correct?
Yes, that's right.
Right. So there, one thing that Randy mentioned about the trusted execution environments is a good way of going about it. For instance, if I could validate everything that is being generated at the edge from a device that I do not know anything about, but I can trust a root certificate, so something like an Intel certificate, right? And using that, the device is telling me that I've created this data and I've signed it. And guess what? I ran it in a trusted execution environment, and I can give you the audit trail for all of it. That is something that you trust. Now, on the cryptographic side, people have been looking at verifiable computation because once you generate the data, that I need to verify. Once you compute it on the data, I need to verify, and I need to marry the two verifications together and give it to the end user so that the user is, able to believe it and utilize that information. So there is a domain in cryptography where we look at verifiable computation, and it's cryptography based. Hasn't really scaled very well because it's fairly complicated. So at the moment, it's trusted execution environment, auditing the system, potentially doing redundant computing. These are the ways that we have been handling this. I don't trust the ecosystem at the edge. Why would I trust the output that comes out of the edge? But this is still very early days in your to agree with you in that context.
I could maybe add something to that, which is we have a use case where we have a secure energy infrastructure, but our customer needs to access that from insecure browser. It's sort of the problem you're talking about. They need a public-facing browser, and we're not allowed to change that browser, so we can't install software on their computer. But with the NDN infrastructure, the security infrastructure cuts across everything. The fact that this zone of trust of the edge is less secure is, I think, fundamental. It's just the way it is. Like, you have to live with that. But you can encapsulate that data and transport it through the rest of the system without contaminating the other more secure portions of the network, and you can handle it appropriately when it arrives where it's going, knowing that it came from what I'd call a semi-trusted environment. Because you can pass along, that set of data is running in a different trust system than the highly trusted data. That's the way to say it. Sort of like the trust zones we were talking about earlier.
No, that's perfect. In fact, it answers my question. The only concern that remains is edge many times generate specific content to its geography, right? So many times you train a model, you deploy it on the edge. On a website, a particular advertisement is specific to that particular location, right? So it's a generated content we are moving towards, right? Now, for that to have this, I need to, as Jay mentioned, maybe drop it down to trusting the edge rather than the data, right? But that's not the way ahead. The way ahead is probably whatever is generated in some way should be trusted in the public domain, like a global security that we need to implement, which the landscape has to be carved out. How the browsers or where the consumption will happen should be okay to do that, right? Should be okay to say that this is the valid content. So what I was trying to understand is there a way or an architecture update that we can do which will help us achieve that further or push the matters with the OEMs? So that will help. But I think I understood what we are trying to do. So if we have any other comment on this part, maybe it'll help. But otherwise, I got that.
I have a small comment about this. I'm not sure we really need the global trust for the content like local advertisements. So the way, the actual web already moving towards to is the secure objects. So some form of whenever, you have to have a relationship with the, if we're talking about the web, it would be the web page or web provider. So there is a, right now it's a global trust, not necessarily ideal. Like it can be some form of local trust. Like for example, if you go into a bank website, why would you trust somebody in a different state to trust your local bank information? But again, that's beyond the point. But inside this page, you don't really need to have a trust on a global scale because you have a trust with the provider, like who for some reason gives you local commercials. So that's kind of already given you potential relationship or trust relationship derived from that web page, from that provider. And there are current solutions for that. Like, I wouldn't say it's NDN solutions. Maybe they heard Lisha's talk at some point and went develop it. So you can include links and authenticate that this piece of data have to have this hash. And you just trust that information based on that. With NDN, we kind of go into the more extreme case, but not necessarily. We don't need necessarily go in a completely extreme case towards the individual data packets. It's like for as long as you can authenticate the data authenticate like sub-data, and hopefully authenticate the processing of the data. That would give a great solution. But the last part is much more complex.
Without going back to my slides, I have two more questions left. So one is about identifying actionable steps to move forward. I don't know if anyone wants to say something. I just make a personal observation. I think there's a strong tie, as I can tell, from yesterday's discussion to today's panel, which is very clear. We need two things. The number one, we need to agree on this identifier or identity question. What is that namespace? We actually will have identity identifiers across board for all the different entities, like Randy mentioned during this panel. There's of course human activities. There's this non-human agent these days coming into play as well, and in addition to three other things, I lost exactly what they are now. And the second thing, and directly after or following this identity question, is really the trust management, or how we can build a decentralized trust management instead of following the current practice of the small centralized web PKI model. I can see that two things standing out very clearly from my angle of the picture. But with the timing running out, I would say that what about the panelists? Give us your final words of departure. What do you want the audience to remember from this discussion? So we go the other order. Maybe we start with Jay.
Thank you. So my thought here is what we are seeing with the proliferation of the edge. The problem, as many of us alluded to, and also several of the students also mentioned, it's becoming more complicated. So this actually opens up really interesting and challenging problems to solve. So this will result in many PhD dissertations and startup companies as a result of this. So this is a great ecosystem to be operating in my opinion.
Okay. Zane, next.
Yeah, I would echo a little bit of what Jay was saying. I think once you start thinking about security problems as data authentication problems, you'll realize this is kind of an underlying thread for a lot of the security issues that we face. Just because we have existing PKIs, mature ones, I think we shouldn't necessarily accept those as the capital right way to do things. And, we should be thinking and constantly reevaluating kind of what different systems need and whether the PKI fits those systems.
Thank you, Zane. Randy?
I guess I would echo some of Jay's thoughts, which are, I think the key is to find opportunities that you don't compete head-to-head with people with centralized solutions, because they will win. There's too much horsepower there, too much money. So edge is a good place, and also things like critical infrastructure is a good place. And the other thing I would say is stop talking about security and start talking about identity. I think the industry's ready to start hearing that message, because it really becomes obvious when I talk to industry people about how do you identify an AI instance. Everybody's like, oh, I never thought of that. And it becomes a very deep problem very quickly, and they immediately become open to deeper discussions. So I think identity is a much more useful entry point to conversations than security overall. People see security as a painfully solved and expensive problem and don't engage easily.
Thank you, Randy. Now,
and if I give I don't know whether it's an answer to this question or summary, I want to echo one of the questions that was here. What was first, the application or the technology? That was for the selling point, but I'm rephrasing a little bit. What I want to say is security is invisible until it's broken. So therefore, we have to have some form of a selling point technology item. So you have to have description and a selling. I mean, otherwise you cannot sell. Like, you cannot just say, "Oh, this app is secure more than this secure," because you cannot compare. It's not comparable thing. Like unless you're able to break something or eventually something is broken, then obviously you can sell it and everybody is panicking about that part. So that's one point take out from this conversation. And the other one, I think this was already in works. Everybody was thinking about this. Like in this conversation, we have multiple times how to do some form of a provenance for the computed data. Like we have to have it. Like it appears in so many different contexts. Even today, it's for the critical infrastructure, for the AI data processing, for regular data processing. We have to have. This is very complex problem. Not necessarily we're going to have a solution anytime soon, but that's interesting to think about it, and I think it's going to be a very complex problem to solve.
Thank you, Alex. So let's give a round of applause for our finalists.